quantitative analysis, looking at numbers. So since most of you have already taken statistics for social science research, this stuff should be familiar, and I'm not going to get into it in too much depth. So quantitative analysis is where we're using numbers to represent observations. You guys might recall that we're using numbers in most of our data sets, even when we're representing things that don't have to do with numbers, right? So like male is generally coded as 1, female is coded as 2. Race might be coded as 1, 2, 3, 4, 5, and each of those numbers stand for something else. This is important to remember when doing our statistical analysis, because it does mean SPSS will calculate things for us that don't actually apply because they're coded as numbers. So when we talk about empirical research, we're talking about scientific backed research, and it uses usually some type of statistical analysis. So statistics is a branch of math, obviously, right? Our statistics can be descriptive. They describe the data. This class has 35 people. It has X amount of women, X amount of men, the racial breakdown, the GPA breakdown, right? It's describing the group. And then we can use inferential statistics that help us form conclusions. Based on looking at the sample, based on comparing, putting together mathematical models, we can come to some conclusions. So as I mentioned, we're often coding our data numerically, right? So if we were to look at a code book for a data set is going to tell us how the data is coded, what the questions were, what the options were. Okay, so it's a primary guide in the coding process, not the cooking process. That would be called a recipe. Okay, so for instance, this is from, I believe this is from the YRBS. It might be from something else. Okay, so they have 2 different variables for race. One is the initial 7 category breakdown, which includes American Indian, Alaskan Native, Asian, Black, Hispanic, Native Hawaiian, Pacific Islander, white, and then multiple race. And then that's disaggregated data, right? And then it's been aggregated into 4 categories: white, Black, Latino, all other races. Okay. Now the reason it's important to know this is coded as numbers is because if you ask for the average race, because this is coded as numbers, the software will calculate an average for you, but there's no such thing as an average race. Now we have a couple different terms we can use here depending on the number of variables. We're looking at a univariate analysis. These words sound fancy. Uni means 1, variate means variable. 1 variable at a time. Okay, this would be like an average or a frequency distribution. So for example, the number of men in a sample, the number of women in a sample. Bivariate analysis is going to look at 2 variables, and multivariate analysis is going to look at 3 or more. So here's a distribution chart of the relationship between victims and offenders in statutory rape cases. Okay, so you can see that nearly 40% of them are acquaintances. Only 31 cases are the person who is being babysat. Boyfriends and girlfriends, child of boyfriends and girlfriends, right? So this is a frequency table. You guys might remember this from statistics. The column with N is telling us the number of cases, and the percentage is telling us the percentage of all the cases. Now, we can use the data, if it is measured at an interval level, we can use that to calculate an average. If it's measured at the ordinal level, we can use it to calculate only a median or a mode. Interval level, we can use all 3. Let me back that up. Okay. A mode is the most frequently occurring attribute. The majority of this group is women. Okay, so if you look under sex, you'll see 93% are women. That's a mode. Okay. For sex, that's the only measure of central tendency we can calculate because of how sex is measured. Okay. For age, we can also calculate a mean and a median. Okay. So we can calculate the average, which in this data set, the average age was 14.46, and the median, just as many were above as were below, is 14. Okay. Notice for offenders, the average is 22.6 and the median is 20. Now the reason the average offender age is older is that the average offender age in this data set ranges from 12 to 80 plus, okay, and the victim ages only range from 12 to 18. We can also measure dispersion. This is how is our data spread out, whereas measures of central tendency is where does our data cluster. Dispersion is the values around a central value, usually the average, okay? You guys remember we talked about standard deviation and variance. Those are those numbers. Those are measures of dispersion. Now, variables can be continuous or discrete. A continuous variable is, forms a steady progression. Something like age or income can range from 0 to whatever, right? That doesn't mean you have to have a 0. It just means like age, if I've measured age in years, that's a continuous variable. Discrete variable means the attributes are separate from one another. They're not continuous, so something like gender or religious affiliation. Now, a bivariate analysis is where we look at two variables for the purpose of determining the relationship between them. So here we're looking at the relationship between gender and relationship between owning a gun, okay? This is the kind of table you've seen a million times in your life. It's called a crosstab or a contingency table. So if you see somebody talk about those, don't be like, oh, what the hell kind of table is that? You've seen these a million times, right? So that first box is telling us 49% of men own a gun, 24% of women own a gun is in the second box. That third box says 51% of men do not own a gun and 76% of women do not own a gun. You can also represent this data in this other cute, adorable way, right? So what percentage of women favor equality? 80%. What percentage of men? 60%, right? So also a contingency table. You might not be able to see it that well because this little thing with my face in it might be blocking it. So finally, when we're putting our tables together, a table should have a heading or a title that describes what it is, right? If we have a series of tables, they should go in order: table 1, table 2, table 3. Our content should be presented clearly. The tables should make it easier to understand what you've written in paragraphs. The attributes of each variable should be clear. The base that we're using for our percentage should be clear. And if there's missing data, that should also be indicated.